Welcome back, guys. Here I'm with you a few examples how to solve the time domain specifications. Actually, the question is to find all the time domain specifications for the unity feedback control system. So for the unity feedback control system and also closed loop response. So they ask the closed loop response, and our system is this. Okay. So this is a system. So let us draw the block diagram. So the first unit we just draw the first unit. So this is G of S block main system, and for time domain specification for a unity feedback system. That means I have the feedback of unity, and the input is R of S and the output is C of S. So the minor by this unity negative feedback. So by minor reduction we have G of S R of S equal to what? So G of S by 1 plus G of S into H of S. Since unity feedback, H of S is given as 1. So I'll having G of S by 1 plus G of S. Okay. So the transfer function R of S equal to what? So 25 by S into S plus 6 by 1 plus 25 by S into S plus 6. So further calculations, I'll obtain the value of 25 by S square plus 6S plus 25. Okay, so I got the transfer function that is called second order transfer function. Now our job is to compare the standard transfer function with this obtained transfer function. Okay, what is the standard transfer function? So we have the standard transfer function of second order, that is omega n square by s square plus 2 zeta omega ns plus omega n square. Okay, so by by comparing these, I have a value of omega n equal to what? Root of omega n square is equal to 25. Therefore omega n equal to 5. So I obtained natural frequency for this system is 5. Okay, and comparing this I am having 2 zeta omega n equal to 6. So substitute omega n here, so I'll obtain the zeta equal to 6 by 2 into 5, that is 6 by 10, so almost 0.6. Okay, so I have obtained the zeta value and omega n value. Okay, so I obtained zeta as 0.6 since zeta is in between 0 to 1. So I say that the given system is obtained transfer function is underdamped function. So the obtained transfer function is underdamped function. Now let us find the time specifications. So I asked what is the time specifications we have. So the first time specification I said the delay time. So what is the delay time is 1 plus 0.7 zeta by omega n. So substitute this zeta value, omega value, I obtained 0.284 seconds. Okay, and the second specification is race time. So the race time is tr into pi minus theta by omega n. So we have zeta value 0.6. So for this, so theta equal to tan inverse root over minus zeta point square by 0.6. So obtain the theta value. So the theta value, after obtaining the theta value, so this is obtained in radians. There is 0.273 radians. Substitute this theta in here. So 3.14 minus 0.9273 by omega value 5. So obtain the race time equal to, I obtain the race time equal to 0.553 seconds. Okay. Now the third one, so we'll solve this later. The third one is peak time. So the peak time value is what? Pi by omega d. So the pi by omega d means, so this is pi by, so pi by omega d. So the pi by omega d So this is omega d value. So omega n into 1 minus zeta square. So you obtain this value. And pi by omega d, so this 3.14 divided by omega n into 1 minus omega square. After substituting omega and zeta value, so we have the peak time. So the peak time value is 0.7854. And fourth specification is peak overshoot specification. So the peak or the percentage of peak overshoot means, so e power minus pi zeta into root over 1 minus zeta square into 100. And again substitute all these values. I obtained 9.748% of peak overshoot. And again have the settling time, that is 4 by zeta omega n. So substituting these values, I am getting 1.33 seconds. Okay. Now again what is asked is the closed loop response. So we have the closed loop response C of t. So since the zeta is 1, so the closed loop response for the unit step input, we have 1 minus zeta omega n of t by root over 1 minus zeta square into sine of omega dt plus theta. So substitute all these values. I obtained 1 minus 1.25 to e power 3t sine 4t plus 0.9273. Okay. So basing upon this C of t, so what you'll do means, if so this is obtained the C of t closed loop response, and this is so after finding obtaining all of things, we have so what are the values we obtained here, no? So we obtained the time domain specification theta t equal to 0.55 seconds, and t raise time is equal to delay time is 0.28 seconds, and raise time is 0.553 seconds, and the peak time is equal to 0.5785, and peak overshoot is 9.478%, and settling time is 1.33 seconds. And the C of t, I obtained 1 minus 1.25 into e power 3t sine of omega 4t plus 0.9273. Okay. So if I want to draw in for this in the, so I have the designated like this. So the delay time, so I'm mentioning the time 0.28 seconds, and the raise time I have to mention like this. So 10 to 100%, 0.55 seconds, and the peak time it reaches a value of 0.78, and the settling time I have reached a 2% tolerance band, so it takes about 1.33. So if you observe carefully, so my 1 second will be at this point, and again takes almost 33.3 seconds, and the peak overshoot I'm taking, so it's here it got 9.478%. that means it is error of 9% at almost 10%. So if you have so if you divide this 100%, okay, I'm having 50% at this point, and the 10% means at most 10% like this. So this part I'll representing at here. Okay, so at this point what I say is 0.9478%. okay, so the peak overshoot is 9.748%. okay, this is the time domain specifications. Okay, so we have another example. For in this example, the question asking pattern is quite different. Okay, before they gave gain k value, that is some 25 by s plus 6 I gave. Now the function I'm having here is k by s plus 10, and he asking me to find k value, and for the system, the response of the system, we have a zeta value, that is damping factor value, and also asking to find the time specification, that is settling time, peak time, percentage overshoot, and the closed loop response. Okay, now similar we have C of S by R of S. So for this is of a unity feedback system. Unity feedback system. So as we know that unity feedback, we have the block diagram G of S, and we have the unity feedback. So R of S and negative feedback. And C of S by R of S is equal to omega n, G of S by 1 plus G of S. So substitute these values. So I obtained C of S by R of S equal to some k by S into S plus 10 by 1 plus k by S into S plus 10. So further realization, I obtained the value of, so numerator is k, the denominator is s get cancelled. So this will become S into S plus 10 plus k. So further I'll having k into S square plus 10s plus k. So I obtained the transfer function, second order transfer function. After obtaining second order transfer function, we have the standard transfer function as omega n square by s square plus 2 zeta omega ns plus omega n square. Now your job is to compare these two secondary denominators. So after comparing the denominator, we obtained so k equal to omega n square, and obtained 2 zeta omega n as 10. Okay. Now he given the zeta value 0.5. Okay, so by this what you will get is omega n equal to 10 by 2 zeta, right? So substitute this zeta value here. Since we have zeta value here, so we have zeta equal to 0.5, the substitute here. So I'll obtain 2 equal to 0.5, that is omega n equal to a value of 10. So 10 by 2 into 1, so the 10 radians per second. So if we have to zeta value, so we have the k value as k square omega n square. So substitute this here. So 10 whole square, then k value I'll having 100. So we'll end up, we have approached the k value, we got the k value. So I'm having the k value as 100. So I'm getting the k value as 100. So since we have a zeta value, so we have zeta equal to 0.5 already given, obtain omega value as 10. The rest of the things are formula. So the settling time means, now the job is to find the settling time. So what is the settling time? So 4 by zeta omega n. After getting, substituting this, all these things, all this stuff, obtain 0.8 seconds. And the peak time means pi by omega d. So pi by, so omega d is omega n into root over 1 minus zeta square. And again substitute the same stuff. I'm getting p 2p equal to 0.3627, and again the percentage peak overshoot, that is 0. Zeta pi into root over 1 minus zeta square. Again substitute in all these stuffs. I'll obtain the percentage overshoot as 16.303%. Okay, and later our thing is closed loop response, that is C of t equal to 1 minus e power zeta omega n t, 1 minus zeta square sine of omega dt plus theta. After all substituting all these things, obtain C of t equal to 1 minus 1.154 e power minus 5t sine of 8.66 1.1. So theta value obtain 0.76. Okay, now if you want to write, so if you want to further give the response, so simply you substitute all these things and you give it the specification. So the peak time is 0.36, so it takes 0.36 times to get peak, and it gets settling time is 0.8, and the peak overshoot is 16%. Okay, so that's thing. So we have many problems in time response analysis. Only the thing is obtaining the second order function and comparing this with this and finding the zeta omega n value, zeta value. If you want to k, if we ask k means we have to find by comparisons and before pattern. Okay, so based upon the input we have the different responses. So the question, first read the quotient and later you solve. So in some cases they may give feedback h of s some value, you have to substitute that here. Okay. So in the next class we'll deal about steady state errors, and thank you guys.